Thing. Okay, good evening once again. Welcome to the Code Without Barriers virtual meetup. And today's topic is about things to know while using Query Store. And we will be having a bit about Query Store and the basics and intermediate topics regarding that. And today we have Deepthi Kakori, who is going to be the speaker or who is going to be present this topic for us. And she is a Microsoft MVP and also a certified trainer on Microsoft. And she's going to be taking us through the topic for the next 1 hour. So before I give it to her, I just want to mention that the session is recorded. You don't need to record it at your end, and also there is certificate of participation at the end of it. So you need to fill out the form that is shared at the end of it. So make sure you stay till the end and fill out the form to get it. Okay. And as I mentioned, this is Code Without Barriers for the meetup, and we'll also share a Code Without Barriers meetup link so that you can join Code Without Barriers for the females in the APAC region for participating in challenges and also mentorship and a lot of opportunity that they offer for the females in the APAC region. So we don't have their representative joining today, so you had to bear with me for the explanation. So yeah, I'll also drop the link in the chat box. Make sure you join there if you are somebody who's getting into the a female who are getting into tech or already in the tech. They will be able to help you with your journey, and a lot of mentors over there who can guide you in your journey. Okay, I'll drop the link and make sure you check it out. Okay, that's it all from my side, and that stage is all for Deepthi for to get started.
Awesome. Can I go ahead and share my screen?
I'm sorry,
Can I go
is
ahead
that a
and share
question?
my screen?
Yeah, sure.
Okay. Okay. Let me share my screen. Oh, I love that background. Um,
Yeah, we can see it perfectly.
awesome. So, hello everyone. Thank you so much for being here today, Friday evening. I know some folks it's Friday evening, for some folks it's Saturday, or like from wherever you are joining from. Thank you so much for taking your time for attending this session today. You are going to learn something new. If you are already familiar with Query Store, I'm sure you are going to take away one or two things that you didn't know, because there is a lot of content to talk about in this session. So I hope you will enjoy. So I'm going to talk about the things to know while using Query Store. So let's begin. My mouse. So a little bit about me. I'm a database administrator. I have about like 8 years of experience as a TBA, and also I'm a Microsoft Data Platform MVP. I also do organize couple of user groups and also conferences. So I do organize data, Microsoft Data AISF, which is AI South Florida, meaning we talk about data and AI, and also data platform DEI, diversity, equity, inclusion, and also I'm a co-organizer for the cloud data driven user group. All these user groups are available on Meetup. So if you type in meetup.com, you can find all of these user groups under the Azure groups. I can share you the link if anybody is interested while leaving this session. And also, I'm a co-organizer for the data TGIF, meaning thank God it's Friday. So it's based in Switzerland. I do organize with one of my friends. He's also a DBA. And also, I'm a co-organizer for the Future Data Driven Summit, as well as I recently joined Data Bash conference. These two conferences are online and free conferences. So if you want links later, I can provide you. And also, apart from that, I added this little last line exploring life within. I recently started not looking outside the world. I am fed up by looking outside world. But I thought like something is going on within me, so I have to look within. So I started my spiritual journey. Even that, if you wanted to know what I'm actually learning, you can actually ping me later, because all of these things that I described, I think that's the most important thing. I think everybody needs to know. We all are in the ignorance mode, but if you know what actually, who you are actually, then all of these things will fade away. So I think I have to put that point starting and not at the end, even before the MVP, even before my name actually. Okay, so enough of talking about that. So I also have my blog here, dbnuggets.com. If you wanted to know more about like query store or like SQL Server or cloud, Azure SQL topics, please visit my website. I usually blog on that website. So if you want to follow me or have any questions, if you couldn't ask me here, if you wanted to know later, please do not hesitate to contact me. The first link goes to Twitter, DBA Nuggets. The second link is LinkedIn, and third one is GitHub. The I am not using I'm not using I mean like Twitter a lot these days, but I am very much available on LinkedIn, so you can contact me there. So let's start with one of the funny incident that that happened to me in my last on call. If you are a developer or a DBA, you will be familiar with this. So I received a ticket. I mean, I received a pager to my phone early in the morning at 2 a.m. in the morning, weekday. Um, and I opened and they opened a priority one incident ticket in ServiceNow. So I went ahead and saw the details of it. Early in the morning, 2 a.m. I'm already full asleep, like sleep mode. Uh, I was panicked by looking at the sound on my phone. So the incident details goes like this, right? The SQL view is taking forever to run and failed finally. Several months ago, Deepti did something using Query Store to fix the issue. The issue was resolved then and again occurring again now. So can you please implement the same steps to fix the issue? So that is all I got, and I had a database name, server name. That's it. I don't even know what query it is right at this point of time. So the error goes like this. They attached this error and it says the query process ran out of the internal resources and could not produce a query plan. Underline the query plan. It didn't even produce the query plan for that query. That query is so horrible that it didn't even the SQL Server itself gave up and I said like I don't want to produce a query plan for this. Too many too many resources it is taking. I don't want to run this query. So it throws this error, right? So I'm in this phase like not knowing what to do. I for a moment my ego kicked off because I fixed the issue couple of months ago. They mentioned couple of months, but it's been 9 months ago. Now who will remember that, right? But for a moment I was like I felt like a queen, like hey, I fixed the issue. But then I just realized, well, now what did I even do to fix that issue? Square zero again, right? The quill fell down and she's on the square zero. And so to find any issue, you are very familiar with it. If you do not know how you fix the issue, the first thing you do is to search in the Outlook, right? Search in the Outlook email based upon the query. So I also saw the developer online. She's also online, and she's so desperate to fix the issue. So I asked her, "Can you please share the query because you didn't mention in the incident?" Shared the query, and actually the link to the SolarWinds where it will track all the queries. She provided that link. So I digged into the emails by based upon that query and I found it that I created the index with the help of the query store. In the emails, the last time I had this issue, I looked into the query store. I found out the what the issue was, and when I looked into the execution plan, it gave the recommendation to create an index. So that's how I went ahead and pulled that. I saw what type of index it is recommending. I checked if there is that index already on the table. No, it's not there, and it said like 98% of like improvement and impact. So I went ahead and created that's resolved the issue temporarily, right? If it was fixed permanently, then I would not have seen it again. But here again we saw this performance issue. So my next question was, did something change? So I was asking the developer who is on the online again. Did something change? Did the query, did the view itself change? Did you change something or change the objects within the view, or like any indexes that you create? I was asking all of these sort of questions, right? But then she mentioned, no, we didn't do anything. So I thought like, okay, since the query store is already enabled on the database, let me go ahead and dig some deep. So finally, what I did was like, I took the query, like by you, if you have the query store enabled on your database, you will get certain views to run on your database to get the query IDs for all the queries that have executed on the SQL Server. So that's how I were able to figure out the query ID for that particular query. And to my surprise, again, I know I worked on this before, but I totally forgot my memory. I have a very quick memory loss, not even a couple of hours. If I do if I do multitasking, that's when you will see the highest peak of it. Yeah. So again, that is true. That's not a joke. So so I checked the query and I found it's an ad hoc query. It's an ad hoc query. So what does that mean? That means that every time the query runs from the application as an ad hoc query, they change the variables all each and every time it runs. So since it is an ad hoc query, even the simple space or a letter or just a comment can can change the entire query and produce a different query ID. So what I mean is like every time you run a ad hoc query, no matter even if you change a little bit, it will create an entirely new query ID. So in that instance, we couldn't do anything to force a certain query plan. So what I mean by that is by taking the advantage of query store, one of the advantage that you can do is you can actually figure out what execution plan is working better for your queries. If a query suddenly doesn't work properly, as you have the history of the information within the query store, because you enable the query store, right? Once you enable the query store, it will go ahead and collect all the information of your queries that are executing. So you can see over time how your query is performing along with its uh, query plans as well. So one of the advantage is to go ahead and see which execution plan worked well and then force that plan so that no matter what parameter you use next, like let's say stored procedure, this works better for the stored procedures. It will go ahead and use the same execution plan. But here I can't do that because ad hoc query will generate query IDs every single time. How about I go ahead and force all the query IDs? I can't do that, right? Because each time I can't predict the future. I can't predict the query IDs. So I can't do that. So there is no point in forcing the plan by using the query store. I use the query store here to identify the query ID. And then I looked at the query itself, what they were running in complete. So to my surprise, they were like using extremely large number of values in the in clause. So they are literally searching on each and every value within the table. So when I did select star from the table, it gave me like 30,000 records, I believe, and they were using each and every value of the 30,000 rows. So they were searching on 30,000 values. Now imagine how much that query looks like. Now that's ridiculous, right? So we can't even force the plan. So I told them like, hey, how about you do two of the things. First, go ahead and use select subquery within an in clause, and um or just remove the where clause incomplete and just pull the entire table into the memory on the console app server itself. So that is what I recommended. In the middle of the night, I was searching. This is not like I'm not an expert, right? So I just went ahead and Googled the error, and I found these two, and I put in front of them. See, these are the two things that these are the workarounds. Now you decide what to do. But I believe the second one will be easier because the change will be quick if you can just pull in the entire table. So they just went ahead and did that, like they remove the weight loss, the second option they choose. So that's how we resolve the issue The next time we executed the query, it was within the fraction of seconds. And until now, I think this happened like couple of weeks ago. And until now, I did not see any other issue with that query. So how did the query store actually help, even though if it is an ad hoc query, right? So I was able to identify the query quickly. I got the query ID. By looking at the query ID, I pulled up the plan, execution plan. I checked the execution plan and the query, and the execution plan itself is so messy uh, because it didn't work uh, all the time, right? It worked previously. So I checked the previous execution plans and stuff. So I did that by using one of the graphical user interface reports that the query store have. So once you enable the query store, there are certain um, reports that you can actually use to see all of that information. So one of the report name is top resource consuming query list. I used that, and also it helped me, at least for the first time, it helped me to help me to recommend an index, and I created that result for the first time, right? At least it saved so much of time. The query executed, again, not permanent, but they did. But if you observe carefully, we actually fixed the problem in complete, like, we did not do the temporarily fix. We did a permanent fix by changing the code itself, because the code is terrible. So as I mentioned, since the ad hoc query, we did not force the plan. But if it is not an ad hoc query, in your case, if it is a store procedure, you can actually leverage and take the advantage of plan forcing with the query store. And I was able to see the entire query and its plan, like I mentioned. And also it helped me make decisions quickly meaning not in minutes, but hours, I can say. But still, to, developer was there with me for me to figure out the issue, do the Googling, get the details, and let them know they have to change the entire code. It took a couple of hours, but permanently we fixed the issue. So that's how actually it helped, like, query store really helped me to resolve the issue, no matter if it is ad hoc query, right? But today, starting with that example, let's see the agenda, what we are going to talk today. We are going to talk about the evolution. You need to know not when the query store started, but how is this query store going, and how is it in SQL Server 2022. So we are going to see that, and we are also going to see the fundamentals of query store. It's very important not only to know how to use it, but actually to know how it actually works behind the scenes. Right now, if you are stuck with something, you need to know to trace back again, to figure out where the problem is starting. If you can know the internals of something, it really benefits you. So we are going to see that. We are going to see the benefits of query store, advancements in SQL Server 2022, and best practices and things not to forget while using the query store, and a demo. I'm going to show you how to configure the query store, because it is very important to know how to configure. If you do not configure it properly, then you will see all sort of problems, all sort of different problems, performance problems and everything, because of the query store. So we do not want that. We want query store to be helpful, right? So let's see that. So let's talk about fundamentals. As I mentioned, query store, it's not released couple of years back, but it got released in SQL Server 2016. If you buy a SQL Server, you will get the query store with it from SQL Server 2016. You do not have to buy it again. And it is not a server level option, it's a database level option. So if you want to use query store on couple of databases and not all the databases, well and fine. You can go ahead and enable it on each database that you desire to enable, and also that you desire to capture the information. If you are seeing some performance issues and you couldn't figure it out, no matter, even if you have SolarWinds or like any other monitoring tools in place, you want something to be shown inside the query inside the SQL itself, you can enable the query store from SQL Server 2016. So once you enable, right, um, I will talk about that later, but let me cover up a couple of things here. It's available in SQL Server 2016 and later, and also it is available by default on Azure SQL Database and Azure SQL Managed Instance. And also it is available on Azure Synapse Analytics, dedicated SQL pool only. But you can't enable, excuse me, you can't enable Query Store on master or TempDB. Now they are system databases. You can enable on the model database, but you can enable it on the model database, and anytime you create a new database, it will get all the settings from this model database. But your databases might be different on a single server. Some databases are little, some databases are bigger. So you need to configure the query store based upon the size of your database and what sort of queries you wanted to capture. Very important, very important. So let's talk from the SQL Server 2016, how the query store actually evolved until 2019, because 2022 I'm going to talk in the later slides. So from SQL Server 2016, that's when Query Store got introduced, right? So when you enable the Query Store on the database in the properties, um, you have an option to choose. You can either do it through graphical user interface or by using the Transact SQL, right? So once you do that, it will go ahead and capture the query text, query plans, runtime metrics on all of your queries. Um, and it will provide you the graphical user reports, interface reports, where you can see all the execution stats information, CPU, memory, IO, all of that information. And then the main advantage was to force a plan. Now, plan forcing is temporarily fixed, but not all the time you will be able to um, fix the internal problem within the query all the time. Um, During the business hours, if you're having this issue, not all the time you will have the ability to go ahead and make the change to the code, right? You need to get a lot of permissions, and sometimes your vendor will won't even agree to that. So in that scenario, plan forcing will be very beneficial, because all you're doing is forcing an execution plan and not touching the underneath code. That's SQL Server 2016. Now, if we move to SQL Server 2017, they did an advancement which is known as automatic plan correction, which is available in Enterprise Edition only, as well as in Azure SQL as well. In Azure, by default, it is available. So when automatic plan correction is turned on, then you do not have to manually force a plan, but give the uh, give the um, give the ability to query store to make the decisions for you. It will continuously monitor the execution plans. If there is a bad execution plan that got newly created, it will go back and always force the last good plan. And also it will collect the per plan wait stats. Until then, until then, wait stats information is not available, but from SQL Server 2017, wait stats information is also available. Now let's move to 2019. That's when they actually thought, let us not decide what to collect, but let the customer decide what they want to collect, right? What sort of queries they want to collect. Custom capture policies will give the ability to the customers to go ahead and choose what sort of queries have to be captured inside the query store based upon two factors. How many times the query have to run, you will be deciding that, and how much CPU threshold the query have to hit so that it will be captured in the query store. And also they introduce plan forcing for the cursors as well. Now, what sort of data it will be collected? It will collect the DML statements such as select, insert, update, delete, merge, and bulk insert. And it doesn't collect the DDL statements, for example, the create index sort of things. But all the time, it will collect the cumulative resource consumption. It won't collect, you need to know this, this is important. It won't collect the resource consumption information for one execution. It will collect as a cumulative information for each and every interval. So when you enable the query store, there are intervals, right? By default, every 15 minutes, there will be a new interval starts. So within that 15-minute interval, no matter how many times the query runs, there will be only one record allocated within the query store, and all the resource consumption information will be accumulated and will be shown in that one record. How do query store works? That's what I wanted to say. I took so much time to put this slide together, not this, but the next one. Um, so how the query store actually works behind the scenes. You need to know that. So let's assume we are running. So half of this slide is a regular, even without query store, but half of this slide also explain how the queries queries running on a database where we enable the query store and also we enable the plan forcing on that particular query. How does that act? So keep that in mind whenever a query runs, no matter if it has the query store on or off, right? Every time it runs, the query engine will check if the query is running for the first time or if it is reoccurring. Now, if it is running for the first time, it will go ahead and do the compilation and optimization. It will go ahead and do all of that steps behind the scenes, and then it will build the execution plan. Now, if it is not running for the first time, it will go ahead and check if the plan is already in the cache, in the plan cache, I mean. Now, not all the time the plan might be in the cache because if whenever the SQL engine is restarted or when there is a rebuild of statistics, the next time you run the query, the if you do not know, whenever you are whenever you are like rebuilding your statistics, right? Table statistics, SQL engine have to force the compilation and optimization on the queries that they run the next time because the rebuild statistics happen. It have to go through the recompilation and optimization phase and build a new execution plan. In that scenario, it will build a plan. But what if this plan is already in the cache? Then it will go ahead and use that plan. Think, all right, take that plan from the plan cache. Very quick, right? But if you are running a query again on the database which you enable the query store on and you are forcing a plan for this particular query, then that's when this step will kick in. It will check for the recompilation. Yes, I did. Finally, recompilation. Okay. So now it will go ahead and check whether the plan that it has actually created, because it didn't find in the cache, so it created a plan, or the plan that it has taken from the cache, right? It will go ahead and check if that plan is similar to that force plan. Again, we are using the query store, right? We force this plan. So it will check if it is similar. Now, sometimes it won't be similar. It's a rare scenario. But if it is not similar, then it will go ahead and recompile again to make it similar to the plan cache. Like, not plan cache, sorry, the forced plan. It will go ahead and recompile, build a plan which is similar to that forced plan. Now, what if it finds the same plan similar to the forced plan? Then it has nothing to do, right? It can move forward. So it will move forward, and the next step that happens is it will save the query text and the query plan of that particular query inside a plan store. Now, what is this plan store, right? This is new to us. Now, whenever you enable the query store on the database, there are certain stores that get enabled in the memory. Now, one of them is the plan store, and the other one is the runtime stat store. The plan store will save the query text and query plan asynchronously even before the query goes to the execution phase, because the query doesn't have to run to get that information, right? It's a simple information: query text, query plan, simple. So it will save that asynchronously and the query goes to the execution phase now. Once the query executes in complete, then the runtime stats information will be saved inside the runtime stats store. Again, this is in the memory, right? So runtime stats anytime. Runtime stats are only collected once the query gets executed. If somebody asks you in the interview, yes, it won't be collected before the before the execution. It will only collect after the execution. Runtime starts, right? And then once this information is collected in the memory, then all of that information will be again asynchronously pushed to the disk, which is known as query store schema. Query store schema always resides on the primary data file of the database. The database where you enable the query store, it is always saved inside the primary data file of the database, primary file group. These also happen asynchronously, and you might be having a question, but how does that happen, right? How frequent that happens? It happens every 15 minutes by default. That's the flush out interval, but you can change that, and sometimes um, even before 15 minutes the information will be flushed out to disk. It doesn't mean that always 15 minutes have to hit. Sometimes it will hit even before that, it will flush out to disk, which is a good thing again, because whenever there is a memory pressure on the server, um, it needs some space in the memory. So SQL engine will go ahead and flush this to the disk even quicker before hitting the interval. So that's how the query store runs behind the scenes. Now, what are some of the benefits, right? Some of the benefits, like I mentioned, when you enable the query store on the database, you will see a folder named as query store within the database. When you expand the database, you see the query store folder, and underneath the query store folder, you see some of the reports. Now, if you see the first report, regressed queries, meaning like any queries that are performing low, like it has a nice execution plan, but later the terrible execution plan were there, and queries are like performing badly. That report will show that. The next one, overall resource consumption, name suggests it will give you the overall resource consumption of your queries. The third one, top resource consuming queries. This is the most I always use because it will give you the list of the queries that you are actually looking for. The next, queries with forced plan. If you forced any plans, right, by using the query store, that's all those queries will be shown up here. Queries with high variation, as name suggests, any high variations will be shown here. Query weight stats, for the weight stats information, look at that report. And tracked queries, that is very beneficial. If you wanted to track any particular query, and if you have a query ID, by using the query store, you can grab the query ID, right? But if you are tracking, if you wanted to track that query, by using this report, you can actually search on that query ID and you can track that query. So those are one of the benefits. And the other benefits is like you can easily identify the regression that are happening between the queries, right? Because the first report shows the regressed queries. And you can quickly fix the non-optimal plan usage. If you have a store procedure that is working well, but suddenly it is working terrible, you have the ability to go back and see how it used to work before, because you can see the execution plan as well, right? Now that will give you the ability to fix the performance of that particular query by forcing a plan without even touching the underneath code. That's the beauty of query store. Now, personally, I used Query Store as a DBA. I used Query Store on each and every database migration that we did, from the older versions of SQL Server to the newer versions of SQL Server. So we migrated from 2016 to 2019, and every single database we did this. Now, what did we do? Once we migrate the database from 2016 to 2019, I'm just mentioning the example of versions here, but it can be anything, right? It can be anything above 2016 because that's when Query Store got introduced. So once we migrated the database from 2016 to 2019, we brought the database to the new environment, right? New server, new environment, new resources, everything, upgraded version. But still we put the database in the old version compatibility mode. We didn't change the compatibility mode. Usually we'll go ahead and immediately change that, right? But we don't want to change that because we want to capture the baselines, how the database used to work in the old environment based upon the resources that we like, based upon the compatibility mode and stuff. I understand that we upgraded the engine itself, like we upgraded the engine, we upgraded the new Windows machine where the SQL Server is hosted, we increased the resources, CPU, memory. I understand that. But what actually changed was the compatibility. Even the compatibility change will make several modifications within the engine. So we wanted to keep the same compatibility mode 2016 and then enable the query store on the top of that database if you didn't have. So once we enable that, we will run all the queries. We will run that workload at least for 1 week. If the database is really big, we need to capture all the queries, right? So we will capture most of the queries. And then once we know that we capture all of that, we will go ahead and shift that compatibility mode to 2016 to 2019 and then run all the queries again. The application will run as is, and like there is no downtime in this, right? All the queries will run. But the advantage is now once you upgrade your databases and once you migrate your databases, most of the times they perform well. But sometimes that doesn't happen to certain queries. Certain queries will perform terribly. So in that situation, as you have the baseline in place right now, after you upgrade the database and after you change your compatibility mode, you have the ability to go back and see how your query used to run before within that new environment. You can go ahead and see within the query store how it used to work before, so that if you got like, because you see in the query store, you also have the ability to see the execution plan. Now because you have the execution plan, you can go ahead and force that plan. Again, that is a temporary fix, but still, once you upgrade the um, databases, once you migrate the databases, there can be several other issues that you have to deal with. And this is one of the best way to resolve the problem very quickly, not permanently, but very quickly, and then take your time with the developer to actually see the query itself, to resolve the issue permanently, to fix the query itself, to see if that is something related to execution plan stats or like what's going on, because the cardinality estimation also changed, right? The cardinality estimator changed in between, so maybe you can also see if that is the reason of why the query is performing less, performing low and not working properly. You can see that. But this is the best example I can say how I use query store, one of the best examples. And the other one was like this is an advancement to SQL Server 2016. In SQL Server 2017 and above, and if you are in the enterprise edition of SQL Server, you can take the advantage of automatic plan correction. Now, once you enable automatic plan correction on the SQL Server, again, this is by default enable on the Azure SQL database, right? Remember that. So once you enable that, the SQL the SQL Server will continuously monitor your queries, and if there is any regression, meaning if there is any low performing queries, they were running fine before, but now they create all sort of like all new query plans which are terrible. They take longer time to run. It will actually see that as an observer, right? It will learn, observe, and then think like, now this particular query got a new execution plan and it is working terribly, but let me look at the old plan. Since I have the query store, right? It will go ahead and observe, and it will go ahead and automatically force that last good plan for you. So it won't stop there. It will go ahead and continuously monitor your execution plans and like workloads and everything. It will verify, and then it will automatically force and unforce the plans for you. That's automatic plan correction. There are a couple of more slides. I believe this is the last slide before I head to my demo. So let's talk about the query store hence, which is released in SQL Server 2022. So if you know the query hints, it is easy to understand what is query store hints. So when you are using query hints, you're actually touching the query itself. But when you are using query store hints, you do not have to touch the query itself. Now, why is that? Is because when they introduced query store hints, they introduced um, a store procedure where you can run to use the query store hints. All you need is two parameters. One, the query ID that you can get from the query store system views. The other one is what query you wanted to, like what hint you wanted to use. Query ID and the hint ID. Not the hint ID, but the hint itself. What hint you want to use. Those are the only two parameters to use to, those are the only two parameters you need to run that particular store procedure where you can enable the query store hints. Now, you might say, you are always talking about the query store hints and telling me how to use it, but what is the benefit of it, right? Why should I use it? So, query store hints are very beneficial in one scenario, not all the scenarios, in one scenario, as an example of if you're having a parameter sensitive problem, parameter sniffing problem, where let's say you have table and you have a lot of skew in your table, meaning um, you are running a store procedure against your tables and you have data in such a way that most of your parameters will give only some couple number of records, let's say some hundreds or thousands of records, but there are these parameters which will give you 1 million or 2 million records. But most of your parameters will give you just like some thousands of records. Now that's a parameter problem, parameter sensitive problem, parameter sniffing problem. That's called a problem because when you create a store procedure or when you update stats or like when you rebuild your stats, the query engine will force to create a new execution plan for your queries, right? Now you are running this query, now you are running this store procedure with that sensitive parameter instead of the normal parameter. The sensitive parameter, which will give you 1 million, 2 million records, you are running that as a next execution. Then it will go ahead and build a plan based upon that parameter, and then it will save that plan inside the plan cache. Now the next time you run the store procedure by using the parameter which will only give you couple of records. Now how do SQL Server handle that? The standard way is to go ahead and look into the plan cache to take the plan out of the plan cache, right? Like we discussed in that big slide, the flowchart that I have shown you. So is it really beneficial for the next execution, which will just produce couple of hundreds of records to execute the plan which actually built for 1 million records? Now just think about the operators that are used inside the plan. The operators might be to do the scan. Just go ahead and scan because I'm pulling 1 million records. Now memory grants, I need hell lot of memory to pull 1 million records. So allocate more memory to that plan. So that memory allocation is already saved inside that plan. So now you are running these next executions with only couple of records, and it will go ahead and use that big execution plans and use lot of resources because that information is saved inside the plan, right? It will go ahead and use so much memory. You do not have to use that. You do not have to scan the entire table for that little number of records that it gives, like couple of thousands of records. So that's a problem. We do not want the scan to run when we just need a index seek and a key lookup, right? So that is a parameter sniffing problem. And by using the query store hints, again, this is just one example I'm saying. By using the query store hints, it's simple that you can go ahead and actually get that query ID and use recompile option. Now, if you do not have query store, usually to fix that problem, you simply change the code, you touch the underneath code and say recompile, bracket, recompile, bracket, option recompile. But we don't want to touch the underneath code. So use the query store hints to take the advantage without touching the underneath code. You use the store procedure get that query ID and use the hint option you wanted to choose. The options can be recompile, max stop, maximum minimum memory grant that you want to use for that query. It can be compatibility level. You can get a lot of query hints that you can use, right? And this happens without under changing any underneath code. So query store hints take the advantage when you are in SQL Server 2022, or if you are in Azure SQL, you still have query store hints there as well. Now, before going to query store advancements in SQL Server 2022, let me go ahead and share my demo. Now, I'm actually disconnected. Let me connect to my server. And let's see, I'm connected to the correct server. So I have Stack Overflow in different server. I hope you are able to see my screen. So like I mentioned, it is very, very important. Not only know how to use the query store, but how to configure is really important. So I took that as an advantage to show you here, like whenever you want to, if you are in SQL Server 2016 or above, go to the database where you wanted to enable the query store, right click, properties, and in the properties you have this option query store. If you are before SQL Server 2016, you will not see this option. From SQL Server 2016 you see this option query store, right? Now let's see the options here. So you have operation modes, three operation modes. Off is like you turn off the query store. Read only, meaning like you can read the forced plan information from the query store. If you forced any plans, right, it will go ahead and read that information, but it can't write any information into the query store. Now, if you choose the read write option, then it not only read the force plan information, but also it will write the new queries into that memory that we discussed, the plan store and runtime start store, and eventually that will those will be kicked in into the query store schema, which resides on the um, primary data file of the database, right? Now that's the operation mode. Now let's see the mm, there is also other modes that we have here. Capture mode, very important, right? When I see this capture mode, how are you capturing your queries? Okay, you turned on the query store, I understand. Turned on the, like you opened the doors of query store. Now whom are you allowing into the query store? Because there is only some space in that room, right? So that's how, like, this is the option which will decide what type of queries you want to capture within your query store. Now all all option will capture everything, even the insignificant queries, even the queries that will run very quick. You do not want this option to be enabled, right? I know, I understand that this option is there. Now why did we have this option if we don't want this? I understand that. But from SQL Server 2017 they actually made auto as a default. So if you are in SQL Server 2016 and if you have your option as all, go ahead and change that to auto, because you do not want to capture each and every insignificant queries, fast running queries. You do not want to capture that. So go ahead and change that to auto, because auto will capture the queries that you want to see, that the queries that might have some issues. Those are the queries will be captured inside it. That's all we want, right? Now how does this auto option decides, like on basis of what threshold, right? Now that information is not given by Microsoft. Again, it is decided based upon how many times your query have to run, as well as what threshold it have to hit, what CPU threshold it have to hit to enter into the query store. So that's the auto. But the none is the third option, right? The none will not capture anything. And custom option is where you can decide the threshold values. You can decide here, if you see the execution count, how many times the execution have to happen, and threshold sale threshold limit, stale threshold when you wanted to um, clean up the stale information. But this is the one I'm talking about, total compile CPU time. You can actually give this value, total execution CPU time and total compiled CPU time. Based upon that information, if the query only hits all of these values, then only, not and or. It's not like that. It have to hit everything, right? So that's when it will go ahead and capture that information. So that's the capture policy that you can do it by yourself, and that is available from 2019. And since I'm showing you 2022 server, all of these options are available. Now let's go ahead and see um, this option, data flush interval. Do you remember when I showed you the flow diagram flow? The last option, like when you want to flush that information that is being captured inside the memory to the disk, that is 15 minutes by default, but I changed to 15 minutes. Again, it's based upon your needs. Just go with what you need. um, Statistics collection interval is 15 minutes by default. It will capture the statistics information as an interval every 15 minutes. So every 15 minutes, no matter how many times within that particular interval your query runs. Let's say there is a query, it runs 100 times within a minute. No matter how many times it runs, it only save one record within that interval, within that query store. Again, it hits the next interval, then again it will get one record. So that is because we do not want to blow up the query store very quick, because each execution, if we capture that within the query store, in with our millions and millions of queries running, it will blow up the query store very easily. So that's why they put it as a interval, and within that interval, the cumulative information, the collected information as an average, it is being collected and it is shown in the views. So you can run the views, query store views, to capture that information. Like you can see that information, and you can take decisions based upon that stats information. So maximum plans per query is 200 by default, but you can change that. You do not have to go below that, but as it is a default, try to change if you want to go above, but you do not have to change if you want to go below. Again, it's your decision, but it's a default 200. Maximum size, I think it is 500 in 2016, and from the later editions of SQL Server, they changed that to 1 GB. So start with 1 GB, but then based upon your capturing policies and like how much you are capturing, what you want to capture, just see the flow, right? Enable, see the flow, and then change the size accordingly. And also, not only having the size, but also you need to know how you are cleaning up as well. So we have seen the capture mode. We are going to see the size based cleanup mode. Now we have options here, either off or auto. Now please do not turn this off, because if you turn this off, 100% query store space will be filled up, and then automatically the query store will be going to the read only mode. We do not want that, right? So by putting it in the auto mode, once the query store space has been reached to 90%, it will go ahead and automatically clean up the stale information, not the active information. The stale and unused information will be deleted until it reaches 80%. So you do not have to worry about like it's going to the read only mode. So that's when, and like I mentioned, query store threshold days. It will delete the data, old data, unused data, 30 days for 30 days, and any forced plan information, if you have in it, it will not touch that because it is active, right? It is being used. Wait stats capture mode, it is available from 2017. You can do on and off, but you turning query store on, it's very important to even capture this. So put it on, right? So that's the configuration information that I wanted to show you. I have placed the same information in here as well, right? So I can execute that on the database. Again, we are altering the database to enable the query store by using the transact SQL. All you do, alter database, database name, set query store to be turned on, operation mode as read write, and I will be doing that. And then also I will be doing this, the configuration settings that I just described, right? And then if you wanted to see, I explained everything in the comments here. I can share this slides, I mean demo with you later. But if you want to see the options that you choose, execute this to see all the options that we talked about, like how much space you allocated, all of that configuration information is being shown here. And these are the other queries that I wanted to place here to show you how it actually captures that information and how it shows the information from the query store. These are the system views designed for query store that I am executing it. It will show you the query text ID, query text itself, the plan ID, the query ID, all of that information. Now, if you want to see the query store itself, I'm going to show you in a minute in the next demo. So here I have this demo of showing you how I used it in the database migration scenario. Now I would like to clean up all the proc cache. Am I on the right database? Again, wide world importers database here. I'm using a data warehouse. I'm using a different server. So let me connect to a different server. I'm using mix of servers here. I don't know why, but I am doing that. So I'm cleaning up the uh, proc cache so that do not do this in production. I know you know, but just putting it out there. And also I'm turning on the query store read write mode. Now imagine that I bought this database, right? This server is 2019 server. So I bought this database. I just migrated this database. It should be in 2016 mode. If it is not, um, 2016 compatibility mode. Absolutely awesome. I did not change that yet because we want to capture the baseline. So I'm doing the exact same configuration settings on this database as well, like I mentioned. Now, what I'm doing is I want to make sure the database is in the older compatibility mode, 2016, right? Let me execute that. And now, let's say we have so many queries in this database. Now imagine that we already have a store procedure, but what I'll do is to show you what that store procedure contains, I'm dropping and recreating it, but in the real time, we already have this store procedure, right? So this is a store procedure. We are just selecting, doing an inner join and searching on a where clause on quantity parameter value. Now let me go ahead and execute that. Awesome. Now we are in the 2016 compatibility mode. Let me go ahead and clear out the cache and then clear out the query store by running this alter database name, set query store clear will clear out everything. Please do not run that option on production, especially. Now I will go ahead and run my workload now. Let's imagine we have like thousands and thousands of workload. We do not have that much of time in the demo. I'm just showing you one single store procedure, right? But you will wait until you capture all of that information and workload. Now let me execute that. All right, now I'll go ahead and show you how the query store will look like. Now the query store, right? Let's refresh. Now, once you have the query store enabled, underneath the database, you'll see the query store folder. And here, top resource consuming queries I want to see. Right click, view top resource consuming queries. Now, what is this bar graph here? I don't like it. But if you hover your mouse, it will show you the query itself. And if you observe, it is showing you in the parameterized format. I executed a store procedure with a parameter value, but did you see the parameter value here? No, it is showing the query itself as a parameterized format. So that is how the query store actually captures the information. Now, if you want to see the entire information of like what parameter value and what is the exact store precision on all of that, You can actually capture that information within the plan cache because the plan cache contain that information. But within the query store, it will not capture the parameter value. Remember that. And also, I don't like this bar graph. I always wanted to see it in the grid view format. So click on this view top resource consuming queries in the grid format, and that's where we will find the query ID. The store procedure have this query ID, object ID, and then object name as well as the object ID. So um, if you are having um, this is the object this is the object name, right? Object name and object ID and the query ID. So now if you um, move your cursor here, you'll see the query text and how much time it took, how what is the execution count and the plan count, all sort of that information, as well as you can see the plan ID got an ID as well as the plan is shown here. And if you see here, it also suggested the clustered non-clustered index, and if you click on that and like if you see like mixing index details, it will give you this. Now what you will do is you do not want to run this directly. You want to check if all of this already there inside any other index, and if it is there, then you do not have to create, but then add the missing key values or like values here. You just include that, but do not create it again because it takes struggle to keep managing these indexes, right? Whenever your data changes, the data should be also changed on all of these column values within your index. So it's not good to create duplicates. So remember that. And also, I would like to show you the metrics available in the query store. Now, by default, it will show you the duration in milliseconds metric, and it will show you the total duration statistics information, and it will give you the 1 hour, the last past 1 hour information. But you can change that, right? You can change the metrics. If you want to see the CPU time, you can click on that, or if you want to see any other information that is being captured, you can also do that. And also you can also do something else here, change the statistics as well. But also if you see the right side on the top configure, click on that to see if you want to filter out any information, right? Like if you want to get only like last 15 minutes information, or last 5 minutes information, or like how many values you want to see last 15, let's say top 15 only I want to see, click on apply and okay. You will only see the last 15 minutes information. So that's how you can actually filter that, right? And also let me also show you some other thing. Now let's say I already captured all of that information, right? Now let me go ahead and change the compatibility mode to 2019 right now, and now again run the workload to see the differences. Execute, executed successfully. Now come here, refresh the query store. Now if you see for this particular query ID, which is a stock info store procedure, it gave you two different plan IDs here, created an entirely new one. Now, if you are seeing based upon the CPU time, the the next execution after the upgrade, after changing the compatibility mode, it has executed in total CPU time 15 milliseconds. But the first one, if you hover your mouse in the old compatibility mode, it took 28 milliseconds. Now, that's how you can see how your queries were performing. Sometimes, like most of the times here, my query executed absolutely awesome. After the upgrade, after the change in the compatibility mode to 2019, it worked amazing, better than before. But what if in the reverse happens? It can happen. Now, in that scenario, you can go ahead and see the previous one, and then you can actually force that plan. Let's say you want to force this one, let's say. You can click on that plan ID and then click the force plan here. By clicking the force plan, it will ask you, do you want to force the plan 3 for the query 1? If you click yes, it will go ahead and give like little tick mark over here to show you that this particular plan ID is being forced. Now, if you want to unforce again, Click on unforce and then click on yes. It will unforce the plan. Now again, we have been seeing the 15-minute interval. So let's change that to last, no, not last 5 minutes, last 1 hour, and click on apply and click OK. Now you will see both of them, right? Because I clicked 5 minutes, it only showed one, but now it is showing two again. So you need to be familiar with these things, and also you can compare between the plans. Now, to compare between two of the plans, all you have to do is click Shift and select both of them and click this option over here. Compare the plans. By clicking that, it will actually show you the differences, like anything that it is showing like not equal to symbol, that is the thing that it is not equal, but anything that it is not showing, those are equal values. So you can compare between the execution plans, both of the execution plans, and then decide which one you wanted to force by comparing all of these properties, all of these statistics information. You can the resource consumption information, you can actually compare and then make a decision based upon it. Now let me close that. Now that is how I used it in the upgrade scenarios. Now let me go back to my slides again, and I think we are running out of time, but I'll go ahead and quickly move to the hints. Like I mentioned, in SQL Server 2022, by default, the query store is enabled on any new databases. If you are migrating old databases to the new databases, that's when you need to make the change. But any new databases will get that information. It all automatically enable the query store. So the new SQL Server 2022 will use SQL query store information, and all the intelligent query processing features that got introduced in SQL Server 2022 will actually take the advantage of query store. They feed on the query store information and then make their decisions upon all of these IQP features. Memory grant feedback, DOP feedback, cardinality estimate feedback, and optimized plan forcing. All of these IQP features will use the query store information. Query store hints are also introduced in SQL Server 2022. And all of these IQP features will be used once you just enable your compatibility mode to 2022. That's all you have to do. Query store for secondary replicas. Again, this is in the preview mode. So what happened until SQL Server 2019 is you only have the ability to capture the query store information on the primary replica, but now you have the ability to capture it on the read-only replicas as well. So you can decide which secondary you wanted to do to capture that information. Once it captured the information on the secondary, it will send the data to the primary using the same channel. How you will be sending the data from the primary to the secondary? Using the always on availability group, it will use the same channel to send back the data from secondary to the primary. But for this preview to um, if you want to test this out on your lower environments, because you can't do this in production, you can only do this in the lower environments right now because it is in the preview mode. You have to enable this trace flag 12606. It's not in the generally available yet. So to see the data, you will actually see the data. You'll run the queries on the primary, and you will search on the role type or by the secondary name to get the information from the secondary um, server. Now, how do you enable it? Very, very simple. First, you have to enable the query store on the primary replica, and then you have to configure it properly in the read write mode, right? And then um, you will also set for the secondary by using alter database name for secondary set query store to be turned on, and also give the read write mode or whatever mode you want. And again, you have to run this on the primary read write only, because you can't change anything on the read only secondaries. Anything you run, you will run on the primary read write copy only. To disable, again connect to the primary and run this on each desired database. Alter database name for secondary set query store to be turned off. So you have to remember before we finish, you have to remember some important things here. When you want to unforce and force a plan, not for the read on, not for the always on availability groups, but for the regular SQL Server, standalone SQL servers, all you need is a query ID as well as the plan ID to force and unforce the plan. But here you have the third parameter, if you see, and the third parameter represents values 0, 1, and 2. When you choose the um, 0 parameter, that means you want to force on read write replica by default, which is the primary. Number one, if you choose, you are forcing or unforcing on all the read only replicas, which is only on the read only replicas. And number two represents to force or unforce on all the replicas, including the primary read write replica. Now, this is important. If you are having too many ad hoc queries and you are seeing the hiccups in the query store, your query store data is being filled up quickly. Now, take this query, linking that to a document, Microsoft document, um, copy that code and put it in the SQL agent job and run it frequently so that all the ad hoc queries will be cleaned up on schedule from your query store. Best practices, please, please do not drop your store procedures. Just do the alter because once you drop and create, you will get an entirely new query ID for your store procedure, which won't align with the query ID that you collected until now on the same store procedure. So do not drop and create. Just do the alter to keep that query ID in place. Avoid renaming the databases for the queries with the force plan because once you do that, all the force plan will go in, they go in waste, like they won't work. And enable the trace flag 7745 to avoid writing query store data to disk before SQL Server restarts. So whenever you enable a query store and you want to restart your SQL Server for any reason, whenever you want to restart the SQL Server, the query store information that is already captured inside the memory but still didn't get pushed to the disk, that information needs to get pushed to the disk before restarting the SQL Server. Now, this can take several minutes, right? But if that is a critical server and a production server, you do not want that thing to happen. You want your SQL Server to restart as quickly as possible. And if you are okay to lose the data that is being captured within that interval in the memory, then go ahead and turn on the trace flag 7745 because that will help you restart your SQL Server very quickly. Traceback 7752 is another one while restarting the SQL Server. The first one is while shutting down the SQL Server. The second one is while restarting the SQL Server. Now, while restarting the SQL Server, again, there is some system information that needs to get pushed into the memory, some query store system information that needs to get pushed into the memory. Now, that can take some time before your databases come online, so you do not want that thing to happen, right? So enabling trace flag 7752 will help to get your databases online first and then asynchronously move that schema information, that query store system information into the memory later, right? And this is by default enabled from SQL Server 2019. So take that advantage. And if you are in the lower environments, just go ahead and turn this 7752 so that you can take that advantage. But if you are from SQL Server 2019, then it's by default enabled. Some of the things to remember while you are using Query Store. Any query hints that you are using in your query will override, right? If you are using the Query Store hint, that will override any query hints that you are having within your code. Query Store hints are persisted even upon the restart. Query Store hints are table hints are not currently supported. And if you are like any hard-coded statement level hints will be also overridden, and any plan guide hints we are using, even those will be overridden with the query store hints if you are using. if underlying schema changes. This is very important. Like if you are forcing a plan, and if you are going ahead and tweaking or changing or dropping any indexes that are being used within that force plan, then your plan forcing will fail. You need to remember that. Do not change, do not make any changes to the indexes. Do not change the name of the index. Do not change the columns within that index. Do not drop the index and rename it in a different format. If you recreate in the same exact way with the same name, that is okay. But if you're changing any bit of it, that will fail your force plan. The automatic plan correction will also unforce the plan if it is actually forcing that particular plan. So be aware of that. And these are the resources that I actually follow to prepare my presentation. Again, this is just a subset of the actual presentation I have. This is just a small part, but I have been talking about Query Store a lot. But if you wanted to see more examples, more real world examples of using the Query Store, please visit my website dbnuggets.com so that you can see and and take the help of those articles. And I would like to thank you all one more time. And I think we are already out of time. But if you wanted to contact me later, please do not hesitate to contact me. These are my these are all the contact information of mine. Just scan the QR code and it will take you to the place. Thank you. Thank you. Thank you, Suraj, for giving me this
Okay.
great opportunity.
Yeah, thank you, Gauri, also for the time taken to share all those knowledge. And yeah, I'll drop your LinkedIn in the chat box, so anybody who wants to connect with you can directly use that link. And also shared our community link. Feel free to join, and I'll also drop your certificate link, which is a feedback form. You can fill out the form, and you'll be getting it on Monday actually, but you need to fill out the form so that you will get it on Monday. That's it, everyone. Thank you for joining on a weekend as well, and thank you again for Deepti for joining and sharing knowledge with us. Really, really appreciate that. And yeah, we'll see you in the next one, which is on 18th, which is for females for technology region. I'll also share the link in chat box for if anybody who have joined here wants to be participating there as well. Thank you, everyone, and have a great rest of the day. It's already night. Good night, I guess.
Happy weekend, all, everyone. Have a good night. Bye.